Awesome. I'm very happy that you're all still here, that you're interested. We're gonna move to a topic now that is still quite related with the original program, in the sense that I'm also dealing with image recognition and deep learning in the framework of my PhD. Which is a project that we are doing here at Fachhochschule Nordwestschweiz, specifically the Institute Geomatics, together with the French National Railway, the SNCF. And I can give you a brief overview. My professor, Denis Jordan, he's also sitting in the audience, and we are the two main people from the Institute that are working on this specific project. And on the French side, it's two people that are in Saint-Denis. It's a suburb to the north of Paris, where the SNCF has a huge campus. It's a large company, the SNCF. They have around 300,000 employees, I think. So obviously I can only solve a very small subsection of their issues that they have. And one of these issues is that there's a rising number of wildlife collisions, and you can see with the trend modeling here, the red line is the annual monthly average that, except for some dip here that is possibly related to the COVID lockdowns, there are steeply increasing numbers. And also, if you just plot very simple exponential trends there, you can see this is only going one direction in the next years. And these collisions are costly and also, of course, ecologically problematic. And the current system that they use is this large Excel sheet to assess how prone a section of track is to wildlife collisions. So you put in a whole lot of information there, like is the hunting intense, are there fences installed, what type of land use is happening on the rail track, how dense is the vegetation, these types of things. And then you can manually ponder with the weights of the calculation, and it comes out with a risk score between 0 and 100%, saying like how prone this specific section of track is to wildlife accidents. I can show you some of the data points here. They are plotted with the time of the day, from midnight to midnight, and the year. And you can see that there's always a high prevalence spot in autumn, and there's an interesting fact also happening here. This is when the time shift is applied between summer and winter time, and suddenly there are a lot more trains riding in the evening in darkness. So there is no real adaptation of the animals to that, and there's an increase that comes with this with the specific day. It's a jump from one day to the next, and there's a lot more incidents. You see there are some gaps in the data set, and this is not due to data collection, but this one here is because of the COVID lockdowns. So for 2 months there were almost no trains going in France, so there were no collisions. And here you also have another gap that you can see. This was the general strike of the railway. So, I mean, trying to solve an ecological issue here, it seems to me like the best thing to avoid wildlife accidents is to not run any trains. But this is not how they want to solve this problem, so I try something else. And I'm sorry that the slide is in French, but the words are sort of easy, so you can get a bit of an idea what I'm doing to come up with a at least the beginning solution to this problem, because these risk scores here, that is really difficult to actually get all the data together. It takes a lot of work, and it's done very inconsistently, so these sheets, they are not even comparable from one track to the next, and there's no time information in this, and it does get used sometimes as a planning basis, for example, for new fences, for population management, or to erect structures like wildlife bridges that could mitigate the collision risk. But in my system, I try to automate this process and make it applicable over the whole network of the SNCF, which is vast. It's 30,000 kilometers. And I'm attempting in a first step now to get down to kilometer resolution to predict the risk. And for this, I want to use multimodal a fusion model that utilizes machine learning and feeds out of various data sources that I am collecting over the databases that either the SNCF has or that we can derive from satellite data, for example, or also own collected reference data sets. Let's first start with that. How do I actually get to the amount of animals that are on the rail track, because this is not something that you can simply look up on the internet. So one option is to use camera traps, and you can see here a map that I plotted for you. There's just some points of interest. The yellow POIs, they are some hotspots on the railway network where there are a lot of accidents, and I'm placed camera traps there. So those are monitoring in the field, like you can see a little example here. Over quite a time duration, animals, they get triggered by motion sensors, and also what is an option is to fly with a thermal drone and then run a computer vision algorithm on that to try to identify which type of species has been seen on the thermal feed. One issue with the camera traps is because it's a large quantity of data. It's about six terabytes that I'm expecting to have in the end of my project, running over time duration of a bit more than a year, so I can cover 2 hotspot seasons. You can see here some initial results with 300,000 images, and 200,000 of these are empty. There's simply just moving plants on it, or something that is, for me, not even discernible, but triggered the motion sensor. And then there's another quarter of the images, or a bit more, which are trains. Because, of course, sometimes you can't put the camera trap in such a nice way that there are no trains on it. For me, that would be the preferential option, but sometimes it's just not possible because of the way a specific section of track is done. And I'm using 2 deep learning models to analyze these images. The first is called Mega Detector. It's sort of a foundational model, but just out of the box is really good already in deciding if an image contains an animal or not. It can't give me any classification about that. So this is why I'm relying on a second deep learning model, which is called DeepPhone, which is done by the French Office of Biodiversity, and that helps me with deciding what type of animal is on a picture. I always take series of 3 pictures, so that's why even in this subsection of images that I use here, these 12,000 images with an animal, or also these other cases with animal and vehicle, animal and person, I only feed those images that have been detected by the Mega Detector framework into DeepPhone. For the simple reason that this is much slower with the inference performance. This is much faster, Mega Detector. Another data source that can be used is clearly visible wildlife passages. This is the ones that are very heavily used. You can see them by the discoloration of the gravel here, or also when there's clear pathways on the side. And they can be detected with a unit approach. I'm using quite a standard unit implementation with the encoder side being enriched by a ResNet 50, so a 50-layer deep residual net. And that works really well. We're getting, because it's a series of mobile mapping images that get done by measuring locomotives every 8 weeks. We can actually even monitor the development of these very visible wildlife passages, but they are only a small part of the network where the accidents are happening, are that clearly visible. And it was difficult to get training data for this, so a student of Doni and mine managed to augment our dataset by photoshopping wildlife crossings, and that worked surprisingly well. Now coming to the target variable, meaning that when you think as as someone coming from geoinformatics, right, it's a different way of thinking and coming from railway. The railway people, they always think in track kilometers, and for them, 2 tracks running in parallel are very separate things. But from an ecological point of view, they are actually very correlated. So I'm rearranging the railway network into approximately 1 square kilometer size blocks with Voronoi polygons. And then I use the existing data points that are geo-located with the accidents, and I apply a multidimensional Gaussian function that can estimate essentially how far was the last accident away and how many months has it been, and through that I can generate statistics that also include the areas around a certain section of track, and this is under the assumption that a track section that is in the close vicinity of another high accident hotspot also has a higher accident risk. And this is evolving over time and over space. So you can plot this to the network and aggregate it with the camera trap data to at least get some type of idea how often an high occurrence of animals together with the density of trains on the network is resulting in incidents. So this is essentially what I also try to model with the other data sets. For example, I'm using a stack of satellite images from the harmonized Landsat Sentinel dataset. This is something that has been released recently by NASA. And you can use a foundational model that was published with it called Predictive 100M. And this is really nice since it includes multi-spectral information. So you have near-infrared and shortwave infrared information. And I'm doing land use, land cover classification then on 30 meter per pixel scale. And at the moment, we are coming out with an average accuracy of over 80% and mean intersection over union of almost 70%, which I'm really happy about for a complex classification task like this. These are some classes that you see here that are specifically chosen because they are associated with the ecological niche that the wild boar, which posed the largest problem, are associated with. So that's feeding plants or habitats, and all of this information can be relevant to model in a spatio-temporal context. Also including terrain models in my analysis, where I'm trying to do every 100 meters a track section and trying to figure out if the terrain is passable or the track is passable for animals at all, because during the field work, I realized that mostly the animals, they don't like to go really down into a steep valley, cross the railway there, and then run up on the other side again, or do the opposite when the rail is on a really large embankment. So they often choose a spot which the French call passage à niveau, meaning it's more or less level ground on both sides. And this is why I'm analyzing the whole network with high resolution LiDAR-derived terrain models. And there are some issues, especially when you come to construction, like buildings, like bridges and tunnels, that you can see they are part of the surface model, but they are not included in the terrain model. So just using the terrain model might not work for these. So there has to be a bit more complex modeling going on when checking for the passability of the landscape. This is just an ongoing project schedule. I'm still running this until the end of 2025, and we hope that the project can continue because the results look actually quite promising at this point. And a type of like final product that the railway is getting will be a long short-term memory, LSTM architecture fusion model that integrates all these data sources, which I'm testing on right now and optimizing. And this is a visualization of older data sets, and I want to do a detailed prognosis. Like here you can see the risk prediction already on a coarse scale, and I want to come to the kilometer scale with the risk prediction now, at least for the next few years to come. All right, that would be it from my side. If you want to know a little bit more about the project, there's also a website where you can check up on it. And I hope this was interesting and that I could supply a little bit of a replacement talk here, at least for our speaker that didn't show up, and would like to ask you for any questions if you have any. Yes, please. Yeah.
I will bring the microphone.
Thank you.
Your replacement session. Not really a technical question. It's just I was noticing that you have this large increase in wild hogs. We have the same problem in the United States, especially Texas.
Mm-hmm.
And I just wondered, is that something a new phenomena for Europe or for France, or is this?
Well, the problem has been increasing in the past years. I think it was always an issue, but it wasn't as costly, and therefore a certain amount was just considered as being okay. And now we are long past the point, especially when it's happening on the fast tracks. It's relatively quickly that an accident can amount to about 100,000 euros in damage. So it's a single accident, and there's 8,000 accidents at the moment per year. Not all of them are that costly because not all are on the high-speed tracks or block other trains from passing. But this is, you have a similar problem on the road network as well. But it's also an issue because the number of wild boar are simply increasing exponentially at the moment, while hunting effort is not increasing at the same time. So this also has to be taken into consideration there.
Okay, more questions?